Hi guys! Today ipagpapatuloy natin yung ginawa nating mass and enthalpy balance sa ating previous video. And on this lecture, we're going to use energy balance para lalo nating ma-explain yung mga nangyayari dito sa ating evaporator. So in our previous video, nakuha natin itong ating derivation from our enthalpy balance, no? Now, if we're going back dito sa ating single effect evaporator, we already mentioned before that there is no mixing happening between the steam and our feed liquor, no? So, the heat transfer is happening between the liquor and the steam. So, kapag wala tayong kino-consider na heat losses, yung mga heat that is being transferred from the steam papunta sa ating mga heating tubes, it will be equal to the heat that was transferred from the tube to our liquor. And in that case, we can say that our heat on our steam will be equal to the heat in our liquor. And from our previous video, ito yung heat that is transferred from our steam, di ba? Alam na natin. So, that means our heat on the steam is equal to S over lambda S. Alright, and now we are going to use this equation. Hiwalay natin itong or i-isolate natin itong ating S lambda S, no? So we have S lambda S will be equal to LHL plus VHB minus FHF. Okay? So that means our QS is equal to Q, and our QS is also equal to S lambda S, and our S lambda S is equal to LHL plus VHB minus FHF. So, therefore, we have here as Q, which is equal to QS, okay, the heat in our steam, which is equal to S lambda S, and this is equal to LHL plus VHV minus FHF. Okay, so this is the equation that we will be working on. Now, this equation is really good. Kapag alam na natin lahat ng value ng ating enthalpy, we can just directly substitute that dito sa ating equation. But in many cases, hindi yan magiging available sa mga questions natin. So, we have to use another method. And on that case, we have to use energy balance. If you remember sa ating previous video, we had used these equations right here for our enthalpy in the feed and the enthalpy sa ating liquor. Okay, we identified CPF as the specific heat of the feed, CPL is the specific heat of the liquor. Okay, but paano natin nakuha itong equation na yan? So, we're going to do energy balance. So, we're going to derive this equation again. Energy balance is very common sa mga unit operations natin, no? And in many times, it is used as a substitute sa enthalpy balance. Okay, so natutunan natin sa thermodynamics that enthalpy is the sum of the total internal energy and the product of the pressure and volume, diba? So we have H is equal to the internal energy plus PV. Okay, so identify natin itong ating mga parts. We have the enthalpy, and this is our internal energy, okay, of the system. Okay, and this is our pressure and volume condition, no, sa ating evaporator. Now, if we're going to take the total differential nitong ating equation ng enthalpy, we will have dH is equal to du plus pdv plus vdp. Okay, now we have to take note that in many cases, in our evaporator, we are considering constant pressure. Okay, and at constant pressure, our dP will be equal to 0. Okay, so therefore, our dP here is 0, so this will be 0. So, ibig sabihin, ang maiiwan lang sa atin is dH is equal to du plus pdv. Okay, so now let us recall yung ating first law of thermodynamics. Okay, so we have the first law of thermodynamics. According sa first law of thermodynamics, energy cannot be created nor destroyed, but it can only be converted from one form to another, right? So with that, we have our internal energy, which is also equal to Q plus W. Okay, so we also identified this dito sa ating thermodynamic course, no? So we know that Q is the heat at the system, and our W is the work done on the system, or work done by the system, right? Depends sa condition natin. Now, katulad ng ginawa natin kanina, no, we can take the total differential of our equation. So we will have du is equal to dq plus dw. Okay, so remember that we are considering constant pressure here, no? And we also learned sa ating thermodynamics course that at constant pressure, our dw is equal to negative pdv, right? So we can substitute that dito sa ating equation. So we will have du is equal to dq minus pdv. Alright, so now we're going to substitute again itong value ng du dito sa ating equation na nasa itaas. So, let us write that here sa ibaba. So, we have dh is equal to du plus pdv, no? Ito yon, sinulat lang natin uli sa ibaba. Okay? Now, we're going to substitute itong value ng du, which is dq minus pdv. Okay? So, we have dh is equal to du, which is dq minus pdv, then we have plus pdv dito, no? So we have minus pdv and plus pdv, so this will be equal to 0. So this will leave us with dh is equal to dq. So anong ibig sabihin yan? So it means that any enthalpy change is equal to the heat change at the certain condition at constant pressure. Okay, so tatandaan natin, ang naging assumption natin dito, we have constant pressure. So that means, if our pressure is not constant, this equation will not work. But we know that in any evaporation, we always consider constant pressure. Okay, so we're going to use that dito sa ating derivation, no? So, our dH is the change in our enthalpy, no? So we have H2 minus H1. This is equal to dQ. Okay, and our dQ is equal to Cp times T2 minus T1. Okay, and this is what we are going to use. Okay, we are going to substitute that dito sa ating equation dito, itong nakuha natin. So we have S, lambda S is equal to LHL plus B, HB minus F, HF. Alright, so let me write that dito sa ibaba. So we have our S, lambda S is equal to LHL plus V, HV minus F, HF. Okay, so anong pinagkaiba niyan dito sa mga values natin dito ng enthalpy? Our HF here is actually the difference na ng ating H2 minus H1. Okay, so that means we can just substitute this value dito sa ating HF, dito sa ating equation. Now, we have temperature difference here, no? T2 minus T1. Well, T1 here is the reference temperature. And this is actually called as well as datum temperature. And kapag hindi ito given sa ating problem, we are actually considering 0 degrees Celsius. Okay, this will be our TO. We are considering 0 degrees Celsius as our datum temperature, or this is equal to 273.15 Kelvin, no? That is why dun sa itaas, itong na-derive natin sa previous video natin, we have HF which is equal to the CPF times TF minus 0 degree Celsius. So that is what we are considering as our datum temperature kapag hindi siya given sa ating problem, no? So let us just use TO para hindi tayo malito. But we know that this means 0 degree Celsius or 273.15 Kelvin. Okay, so now let us use this dito sa ating equation. So we have S lambda S. Now, we don't have to change this. Okay, hindi na natin kailangan gamitin yung energy balance dahil lalo na if this is steam, we can easily get yung value nito using steam table. Okay, so ipapakita na lang natin yan once we start solving problems. Now, we have LHL, and kapag hindi given yung enthalpy ng ating liquor, then you can use our energy balance. So, we will have L, Cp of our liquor, because we are talking about the liquor here, and then the temperature of our liquor minus our reference temperature, which is 0 degree Celsius. So, para hindi tayo malito, I will not use 0 degree Celsius or 273.15 Kelvin. I will just use TO. Okay? Dahil we are just deriving our equation here. Then, plus V, HV. Now, for HV, this is the enthalpy in our vapor, which is in gaseous form, no? So, hindi na rin natin siya babaguhin into energy balance. Dahil this is in vapor stage, no? Where it is in boiling temperature. So, that means you can also get this value sa ating handbook. Lalo na if our solvent ng ating liquor is water. So, this will be a steam. Diba? So, makukuha din natin yan sa ating steam table. Diba? So, minus F, our HF. So, we can also use our energy balance na derive. No? So, we have Cp in our F times T in our feed, temperature in our feed, minus our reference temperature, which is 0 degree Celsius. No? But I will just write TO for our conversion. No? Okay, so meron na tayong bagong equation dito where we substituted itong nakuha nating equation. Now, let us have a look again dito sa ating diagram. So, we have here a dilute feed. Diba? So, we will be separating some vapor and we will have our thick liquor here. But if the liquor is still dilute, okay, so hindi naman siya masyadong concentrated, it will be still dilute ang nakuha natin dito sa ating liquor, then yung Cp natin dito sa ating system, no, sa liquor, the main contribution will be the Cp of our solvent. Okay, so if we have here a solvent na water, let's say, so we will have here the main contributor ng ating Cp will be the Cp of water, diba? So, in that way, we can assume dahil yung Cp in our feed, which is diluted, so ang magiging main contributor ng ating Cp there will be yung Cp ng ating solvent, no, na water. So, we will have Cp in our feed. And kapag diluted din ang ating nakuhang liquor, so, ang main contributor din ng ating heat capacity sa ating liquor will also be water, no? So, we can assume that this is approximately equal to Cp of our liquor. So, if we will have that assumption, then we can substitute that dito sa ating equation. Okay, so let us change our Cpl to the Cpf, no? Yung Cp ng ating liquid to Cp ng ating feed. So, we have S lambda S is equal to L Cpf times TL minus TO plus VHV minus F Cpf times TF minus TO. Now, let us remember yung ating overall material balance, no, na ginawa sa first derivation na video natin. So, we have overall material balance, which is F is equal to L plus V, no? So, I'm going to express our liquor as a function of our vapor and feed. So, I will have L is equal to F minus V, no? So, now I'm going to substitute that dito sa ating equation sa itaas. So, I will have S lambda S, which is equal to yung L natin, I will substitute this instead of L. So, we will have F minus V times our CP ng feed times TL minus TO. Okay? Minus, we have VHB, but I'm going to put this first para maipagtabi natin yung ating F, no? So, I will have here F, CPF, TF minus TO, then our plus VHV. Okay? So, distributive property tayo dito, no? So, we have S lambda S is equal to F CPF, okay, times TL minus TO. Then, ito muna, para may pagtabi natin yung FCPF. So, I have minus F CPF times TF minus TO. Okay? Then, I'm going to write this because this is distributive property. I will have minus B CPF times TL minus TO. Then, plus VHV. Okay? Now, we have our CPF TL minus TO here. Okay, this is our enthalpy sa ating vapor, no? And since our vapor is in gaseous state, okay, this is also equal to HV, no? Since this is in gaseous form, this will be HV. Now, we will have S lambda S is equal to, I'm going to factor out itong FCPF. So, I have FCPF. Then, I will have TL minus TO. Okay, and then, this is negative, no? So, I will have negative TF plus TO. Okay, then minus, okay, so I'm just going to write this first, VHV plus VHV, right? So, our reference temperature TO right here will be cancelled out. Okay, so, as you can remember, hindi na natin ginamit yung 0 degrees Celsius or 273.15 Kelvin here. Anyway, it will be cancelled out. Okay, so what we'll have here, we have S lambda S is equal to F CPF times TL minus TF, which is the temperature in our liquor and the temperature in our feed. And this is minus, we will factor out V, so we will have V times HV plus HV. No? Alright, so I'm going to change this into positive sign so we can have the enthalpy of our vapor in liquid state first. So we will have SHS is equal to FCPF minus TL minus TF plus V times HV minus HV. Okay? Now, what can you remember dito sa ating enthalpy? No? Nagawa na natin to sa ating previous video. No? We know that this is a latent heat. And we can get this value sa handbook. Right? So, that means we will have our final equation as S lambda S is equal to FCPF times TL minus TF plus V lambda V. Yung latent heat in our vapor, no? So, we have this as our final equation using energy balance. So, gagamitin natin yan sa pagsosolve ng problem. Now, we must not forget yung mga naging assumptions natin dito, no? First, we assume that our CPL is equal to the CP of our feed. Next, we do not have boiling point elevation dito. And we assume also that our TL is equal to TV. So, yung temperature ng ating liquor is equal to temperature ng ating vapor. And, you know, this is the same equation na makikita natin sa McCabe-Smith. So, I will write this down. Ipapakita ko lang sa inyo yung equation na na-derive sa McCabe-Smith. And this is it. We have Q is equal to MF CPF times T minus TF plus MF minus M times lambda. Okay? So, ano nga yung formula na na-derive natin? We have S lambda S is equal to F CPF TL minus TF plus B lambda B. So, I'm just going to write that here para may compare natin siya dito sa itaas, no? So, we have S lambda S is equal to F CPF times TL minus TF plus V lambda V. Okay? So, yan yung na-derive natin. I'll just box it again, ano? So, pareho lang yan ng naandito sa McCabe-Smith. Magkaiba lang kasi yung ginamit nating notation tsaka yung notation na ginamit ng McCabe-Smith. So, itong MF is the flow rate ng feed. Okay? So, we have MF dito. So, kapag may nakita kayong dot dito sa taas ng M, it means this is a flow rate. So, we have mass flow rate here in our feed. So, nandito rin yung CPF natin. And then, our temperature dito sa feed. Okay? Now, itong walang nakalagay na subscript, itong temperature, that is actually the temperature sa liquor. Okay? So, dito sa liquor natin, walang subscript. Okay, so that means yung M natin dito will just be M. Okay, na may dot. Walang subscript. Dito may subscript na F, dito wala. So, this is how they use the notation sa McCabe-Smith. So, ngayon, makikita natin, ano? We have MF, the mass flow rate sa ating feed. Pareho lang ng F natin yan. And by the way, first, our S, lambda S, katulad ng na-derive natin, is also equal to Q. Okay, so, para ma-refresh tayo, ito yun. Our Q, saan na ba yan? Our Q, here. Our Q is equal to S lambda S. Ito yun, ano? So, that's the same as here sa McCabe-Smith. Our S lambda S is equal to Q. Okay, so we have MF, which is the feed, kung F. Then CPF is the same as CPF. Times T, the temperature of the liquor, dahil yung liquor natin is walang subscript. So, we have temperature of the liquor minus temperature of the feed. So, same, no? Plus, MF minus M. And we have here the flow rate or mass flow rate of our vapor. So, it is because the mass flow rate of our feed, MF, minus the mass flow rate of our liquor will be the mass flow rate ng vapor. So, yan yung nasa overall material balance na ginawa natin, ano? So, this will be V, the flow rate of our vapor. So, pareho lang din yung tinutukoy niya dito. Then, itong latent heat ng ating vapor. So, basically, the same na ang nating na-derive dito sa equation na nasa McCabe-Smith. And what's important, kaya ako ito pinakita, because in McCabe-Smith, they are explaining kung ano ang ibig sabihin nito. So, if the temperature TF, so yung temperature ng ating feed, which is also called as tin liquor. So, tin liquor, no? Ito yung term na ginagamit dito sa McCabe-Smith. Tin liquor. Okay, so underline natin ng red para madaling makita. Okay, so this is tin liquor because this is understood to be dilute. And ito namang liquor natin dito is thick liquor because this is more concentrated kumpara dito sa ating feed. So, TF is the temperature in the tin liquor, which is our feed. So if our TF is greater than T, so in this case, what we mean is that if our TF is greater than our TL, okay, so mas mataas yung temperature ng ating feed kumpara sa temperature ng ating L, so you can just imagine that mas mainit itong ating feed kumpara dito sa heat na naandito sa ating evaporator. So, what does it mean? Hindi natin kailangan tong supply ng steam kasi mas mainit na nga itong feed natin. Ano? So, what will happen is that our value here will be negative as stated here and is the net enthalpy brought into the evaporator by the tin liquor. Okay? So, this item is the flash evaporation. So, kapag mas mataas ang temperature nito, that is what we call flash evaporation. But, if the temperature TF or the temperature of the tin liquor fed to the evaporator is less than T, yung temperature ng ating liquor or itong temperature ng ating evaporator, the term in MF, T minus TF is positive. Okay, dahil mas mataas yung ating TL kaysa sa ating TF, so TL minus TF will be positive. Okay, so magiging positive yung value natin dito. And for the given evaporation condition, steam will be required to provide this enthalpy. So on that case only, kailangan natin itong steam para ma-reach natin yung temperature na yon. So we are supplying that steam right here. The term MF, T minus TF is therefore the heating load. So in words, equation 16.8 states that the heat from the condensing steam is utilized to vaporize water from the solution and to heat the feed to the boiling point. If the feed enters above the boiling point in the evaporator, part of the evaporation is from flash. Alright, so we are going to use this equation, lalo na kapag nagsosolve tayo ng problem galing dito sa McCabe-Smith. Now, some problems katulad nung sample problem na makikita natin sa Ginkoplis, ang reference temperature niya or datum temperature niya na ginamit doon is yung temperature ng evaporator natin, which is T1. No? So, we're going to use that when we solve a problem from Ginkoplis. Okay, so we will be showing you that in our succeeding video. So for now, ito lang muna. And on our next video, we're going to solve problem na. So with all of that and more, I will see you in our next video.